For centuries, humanity has looked up at the night sky. We saw a tiny reddish spark among the stars. This was Mars. It captured our imagination. It fueled our dreams of other worlds. Ancient civilizations named it after their gods of war. They saw its fiery color as a symbol of power and mystery. This little red dot has always been more than just a planet. It has been a destination, a question mark, a challenge. What secrets did it hold? Could there be life? These questions whispered through generations. Early astronomers with their simple telescopes peered at Mars. They saw polar ice caps like Earth's. They saw dark patches that changed with the seasons. Some even thought they saw canals, straight lines crisscrossing the surface. Were these built by intelligent Martians? This idea sparked a wave of excitement and speculation. Writers like H.G. Wells imagined Martians invading Earth in the War of the Worlds. Edgar Rice Burroughs wrote of adventures on Barsoom, his name for Mars. These stories, though fiction, planted a seed. The seed of Mars as a real place, a world we could one day visit. The dream of Mars did not fade with more advanced science, instead it transformed. We learned the canals were illusions. Reaching Mars is not a simple trip across town. It is a voyage of many millions of miles. It takes months, even with our fastest rockets. Imagine being cooped up in a small spacecraft for that long, 6 to 9 months, hurtling through the blackness of space. This journey itself is one of the biggest hurdles. The spacecraft must protect its precious human cargo. It must be a tiny Earth, providing air, water, and food. It must also shield astronauts from the dangers lurking in the void. This is a tremendous engineering challenge.
One of the greatest dangers is space radiation. Outside Earth's protective magnetic field, space is filled with tiny, fast-moving particles. These come from the sun and from distant cosmic events. This radiation can damage human cells. It can increase the risk of cancer. It can affect the brain. Astronauts on a Mars mission would receive a significant dose. Scientists are working on better shielding for spacecraft. They are also researching medicines to protect astronauts. But the threat remains a serious concern for long-duration missions. We must find ways to keep our explorers safe.
Then there is the problem of weightlessness, or microgravity. Arriving on Mars is just the beginning of the challenge. The red planet is not a welcoming place for humans. It is a world of extremes. Its atmosphere is very thin, about 100 times thinner than Earth's. It is mostly carbon dioxide. Humans cannot breathe it. This means astronauts must always wear spacesuits outside their habitats, or they must live inside pressurized environments. Creating a safe, breathable space will be the first priority for any Martian outpost. This is a fundamental need for survival.
Then there is the Martian climate. Mars is incredibly cold. The average temperature is about -80 degrees Fahrenheit, or -62 degrees Celsius. It can get much colder at the poles during winter. While summer days near the equator can reach a balmy 70 degrees Fahrenheit, or 20 Celsius, nights plummet. Astronauts and their equipment must withstand these huge temperature swings. Habitats will need excellent insulation and powerful heating systems. Power will be a precious resource, essential for warmth and for all other life support systems.
Martian dust is another major concern. The surface is covered in fine, powdery dust. It is like talcum powder, but grittier. This dust gets everywhere. It can clog machinery, it can damage spacesuits. If inhaled, it could be harmful to lungs because it contains perchlorates. We saw how moon dust was a problem for Apollo astronauts. Martian dust could be even more troublesome due to its chemical composition and pervasiveness. Engineers are designing systems to minimize dust contamination. They are thinking about airlocks and cleaning procedures. Keeping the dust out will be a daily battle. Section 4. The Great Martian Race. Nations and visionaries reach out. The journey to Mars is not just one nation's dream, it is a global ambition. Several countries and private companies are looking towards the red planet.
NASA, the American Space Agency, has a long history with Mars. It has sent many successful robotic explorers. Rovers like Curiosity and Perseverance are our eyes and hands on Mars right now. They are searching for signs of past life. They are studying the geology and climate.
NASA's Artemis program aims to return humans to the moon. This is seen as a stepping stone, a place to test technologies and operations before the giant leap to Mars. NASA's plan for sending humans to Mars is methodical. It involves building a gateway station in lunar orbit. Astronauts would travel from Gateway to the Moon, and eventually, to Mars. The target for a crewed Mars mission is often cited for the late 2030s or early 2040s. This approach emphasizes international collaboration. It focuses on sustainable exploration.
NASA is developing powerful new rockets like the Space Launch System, or SLS. It is also designing the Orion spacecraft for deep space missions. These are key pieces of the puzzle for reaching Mars.
Other nations are also making significant strides. China has successfully landed its Zhurong rover on Mars. This made China the second country to operate a rover on the Red Planet. They have ambitious plans for their space program. This includes robotic sample return missions from Mars, and eventually, human missions.
Russia, with its long heritage in spaceflight, also has Mars aspirations. The European Space Agency, or ESA, is a key partner in many missions. They contribute scientific instruments and technology. India and the United Arab Emirates have also sent successful orbiters to Mars. This shows the growing global interest.
Section 5. Building a Martian home. Blueprints for a new civilization. Once astronauts arrive on Mars, they will need a place to live and work. Early habitats will likely be prefabricated structures. These could be landed on the surface, or they might be inflatable modules that expand once deployed. These initial homes must provide protection from radiation, extreme temperatures, and micrometeoroid impacts. They will need reliable life support systems. These systems will recycle air and water. They will manage waste. Every gram of material brought from Earth is precious. So, efficiency is key. A crucial step towards a sustainable colony is using local resources. This is called in situ resource utilization, or ISRU. Mars offers several key resources. We know there is water ice, especially at the poles and buried underground. Water is essential for drinking. It can also be split into hydrogen and oxygen. Oxygen is for breathing. Hydrogen and oxygen can be used as rocket fuel. This could allow future missions to refuel on Mars for a return trip to Earth, or for journeys to other destinations. This would dramatically reduce the mass needed to be launched from Earth. Martian soil, or regolith, can also be a valuable resource. It could be used to 3D print structures. Imagine robots building landing pads, roads, or even habitats using Martian dirt. This would save the enormous cost and effort of transporting building materials from Earth. Regolith could also be used as shielding. Covering habitats with a thick layer of Martian soil would provide excellent protection against radiation. Scientists are studying the composition of regolith. Section 6. Our cosmic destiny. Why Mars calls to us. Why Mars? Why undertake such a difficult, expensive, and dangerous journey? There are many answers. Some are practical, some are deeply philosophical. From a practical standpoint, Mars offers a chance to ensure the long-term survival of humanity. We live on a single, precious planet. Earth faces threats both natural and self-inflicted. Asteroid impacts, supervolcanoes, climate change. Establishing a second home for humanity on Mars would be like backing up our species. It would be an insurance policy against extinction, a profound step for our future. Mars is also a scientific treasure trove. It is the most Earth-like planet in our solar system. Studying Mars can teach us so much about planetary formation. It can teach us about climate change. Perhaps most exciting, Mars may hold clues to the origin of life. Did life ever arise on Mars? If so, was it similar to life on Earth or something completely different? Finding evidence of past or present life on Mars would be a monumental discovery. It would reshape our understanding of our place in the universe. It would tell us that life is not unique to Earth. The cosmos could be teeming with it. The quest for Mars also drives innovation and technology. The challenges of reaching and living on Mars push us to our limits. They force us to develop new solutions, new materials, new propulsion systems, new ways to sustain life in hostile environments. These technologies often have benefits back on Earth. Think of the advancements spurred by the Apollo program, medical imaging, water purification, and countless other innovations. The pursuit of Mars will undoubtedly lead to similar breakthroughs. It will inspire a new generation of scientists, engineers, and explorers. Ultimately, the journey to Mars speaks to something deep within the human spirit.